So you have two pieces of colored paper. One of these pieces is going to be your minor color, and one of them is going to be your major color. I know some of you, it doesn't matter which one, but some of you do, so I'm making sure you understand that we are starting with our minor color. It's the one that's going to not show up as much as the rest. Okay, got it? You got a landscape in front of you, yes? I want you to fold this in half. Okay, I want you to fold it in half. Now apparently this is something of like a stupid human trick, you know what I'm talking about? They have those stupid human tricks on TikTok or something. They used to have it on like Jay Leno or some Tonight Show or whatever, and they do stupid stuff that doesn't really mean anything. Well, here's mine. You're impressed? Okay, I'll bow. There's my bow. Okay? If you can't tear it like that, that's fine. That's why I gave you the scissors. Okay? But fold it so you have a fold to go by, and I need you to cut it pretty straight. Okay? As straight as possible, I need you to cut it. Okay? Got it? Good. Good. We good? No. We're not good? Oh no. Are you okay? Okay. 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 Now, one of these is a present. Just put it to the side. You get to keep it. The other one, I need you to fold it in half. Now, they fussed at me earlier. They're like, I think that's a hot dog fold. And I said, I think it's very rude to talk about hot dogs if you don't have enough hot dogs for everyone to share. Plus, you're 16, 17 years old, right? If I show you what I mean by half, that should be good enough, right? Okay. I need you to tear that in half as well. You folded it, now tear it or cut it. Okay? Fold it, now tear it or cut it. Yeah, see, the best part is if you mess up, you have another one, right, that I gave you as a present to use if you need to. All right, you're okay, though. You're okay. You're doing great. You're almost there. Good. Okay? Now, please take these and put them aside. Okay? Now you have your second piece. For the record, I have a piece of white paper up here because it, like the brown, it's just a big giant like glare. Okay, so I just have a white piece of paper here for that, all right? So I have my second piece of paper right here. I'm going to fold it in half. Okay, we're not cutting yet, okay? Because once you fold it in half, I want you to fold it in half like each side in half again. So when I fold like the sides in and I look at it at the end, it's like I have an M, like, you know, Mrs. Kingston, right? Yeah, so just fold it like that and then fold that one out that way. Okay, good. Yes, yes. Fold it like that and then fold that one that way. Yes, yes. Mostly, yeah. I just want you to like this way. If you're gonna do that one that way, I need you to do that one like that. Does that make sense? So fold the top. So fold the top. Fold that one this way, and then fold that one that way. Does that make sense? Good job. Good job. No, you're almost there. No, you're almost there. Look. Now just fold that one that way. Do what? You're good. No, that's right. Look, Shaylee's so concerned. She's like, mine's a W. I'm just teasing. She didn't say that. Okay? But you understand if it's a W, it's still okay, right? Yeah? Okay? So does everybody have their M? Yeah? Okay. So I need you to take your M and hold it so it's a T. So here's how it was, my M, and then I held it, so now it's a T. Yeah? I need you to turn it on its side. You can't really see where my thumb is right now because it's under the fold, right? But I'm going to take my scissors, and I'm going to kind of guess where halfway is, and I'm going to cut all the way up to the fold, but not past the fold. Does that make sense? Yes? Yes, absolutely. And then I'm going to cut here, about halfway here, and then I'm going to cut about halfway here. So I'm going to make 3 cuts on this paper so that it looks like that. Does that make sense? Yeah, I'll come and help. You're fine. Good, good, excellent. Now what I do want you to make sure of is that you cut all the way up to the fold. You can even go a little bit past the fold, but get all the way for sure, all the way up to the fold. So all the way right there and all the way right there, okay. Yeah, yes, yes, right idea. You getting it okay? So yeah, go all the way up to the fold. You can even go past the fold a little bit, that's okay. But yeah, you want to get very good. So make sure that one's 2. Okay, so far? So now when I open it, it looks like this, right? So now I'm going to make it easier for myself in a minute. And I'm going to like unfold it and fold it backwards. So when I look at it, it looks exactly the same, right? But I've unfolded it and folded it backwards. And that's just to make it a little bit more easy to maneuver. Good, good. You're all doing it right. Good. Okay? Now let's flatten it out. Okay? Now you're going to take one of your 4th pieces, right? And you're going to weave it through. So it went under, over, under. Okay? Yeah, I can help. You're fine. Yes, yes, and then through the bottom. Yeah, perfect, perfect. Now scoot that all the way over to one side as far as you can get it. Okay? So it's all the way over to one side as far as I can get it, because now I need to weave the other one the other way. So that is what it looks like. Good. Yes, yes. Perfect. I know it's awkward. It's okay. Good. All right, you got it? There, that sounds a little bit better. That's good. So now I've just folded it up. Okay? And the way that I have it folding right now, it's like opening on the right-hand side. Does that make sense? Kind of like a book? Yeah? Yes? This way? This way, though? This way? Just like that. So the way I have it is like that. It doesn't matter, but that's just how I have it right now. Okay, we good? All right, let's do some writing. So I'm just turning it this way. It says transformations. Let me zoom in a little bit. You can see it better. Okay, transformations. Maybe the white was better. Got it? Okay. Now I'm going to turn it over on the back. Please don't write my name. Please write your own name. You got it? Yeah, that's good. That's good. Yeah, that's fine. Okay, now I want you to open it up so that it looks like this. Transformations is on the right. Your name is on the left. Okay, transformations is on the right. Your name is on the left. Got it? And then, so that we're all doing the same thing, because it really, honestly, at the end of the day, doesn't matter. But we're all doing the same thing, because I know for some people it matters. We're going to flip it over. Okay? So that the side we're starting on doesn't have anything written. Okay? All right. So I'm going to zoom in so that all you can see is the top two rectangles. Okay? I zoomed in so all you could see is the top two rectangles. Yes. No, you're fine. You're fine. So in this rectangle, we're going to put f of x plus k. Okay, it does that sometimes. I don't know why. If I step back for a second, it'll be okay again. Okay, f of x plus k. It's just being, like, I think it's in a bad mood, the projector, because it keeps doing this. What is the k doing to the function? It's adding, right? The k is adding to the function. So when we have a k that's adding to a function like this, it causes a vertical shift. Okay, causes a vertical shift. Now, I'm going to teach you something really quick on the 6th day of school that's going to be super, super important for you all year. It's like super, super important. You're going to need to know all about all year. You're also going to need to know it next year in math. Okay? Are you ready? I think you are. Guys, you got to remember this F, because if you forget it, that's a different word. That's what you need to know. Why do we have to have rules? Because people have done them, right? Okay. Please remember your F, because without the F, it's a different word. Okay? So, what does vertical mean? What direction is vertical? Up or down, right? That's a vertical change. So if this says plus k, what direction do you think it's going to move? Up. And if it says minus k, what direction do you think it's going to move? Down. Okay? Now in this bottom section each time, we're going to draw some graphs. We're going to draw 2 graphs, so you've got to make them small enough so that you can see them. Okay? Let me try something. Try it. So if f of x right here is the absolute value of x, do you remember what shape that is? Absolute value. You know, I don't normally say absolute value like that, right? What am I trying to give you? A hint, right? Absolute value looks like a V, right? Okay? So what about if g of x is absolute value of x plus 4? Where do you think that is moving the function? 4 where? Up, right? 4 up. So 1, 2, 3, 4. The V is the same shape as it was before. It's just moved up 4. It's been shifted up 4. It's been translated up 4. Do you see all the different words that you could possibly hear? I think there's more, but those are the ones I got for you right now. Okay? All right, are you good with that one? Okay, so we're going to go to the top of the next column. And this one's going to say f of x minus h. But the minus h is all in the parentheses. Do you notice that? F of x minus h. Okay? Well, if k causes a vertical shift, what do you think h is going to cause? Absolutely. That causes a horizontal shift. Okay? Now here's the thing about this particular function. Can I go back up to the top real quick? Where is k in relation to the function? And where is h in relation to the function? What? So k is outside of the function and h is inside. Let's go ahead and write that real quick up here. Outside, because that's going to make a difference for us. If we can recognize if it's outside or inside, that's going to help us. Okay? I'll give you a hint. If it's outside, it's going to cause a vertical change. Sometimes a shift, sometimes something else. But if it's outside, it's going to cause a vertical change. If it's inside, guess what? Horizontal change. Okay? All right, so I have 2 options here as well. I have x minus h, and I have x plus h. Here's the other thing about inside. Okay? Inside, it's actually going to turn out to be backwards of what you think. Because if you look at x minus h, which way do you automatically think that's going to go? Left. Okay, it's horizontal shift, so it's going to go left or right. But you know which way it actually goes? Right. So x plus h, you think it should go right, but guess which way it actually goes? Left. Now, I'm going to let you in on a little secret. We're going to talk about the math real quick. Okay? Specifically about the math. Look up at the equation again real quick. Do you notice that the minus is part of the formula? Like the minus is given to you in the formula. So if this says x minus h, let's say it says x minus 2. Guys, what's the value of h? 2. 2 is a positive number, and it should move right. If this says x plus 5, well, the formula is x minus, so the value of h is actually what? Negative 5. A negative number should move where? Left. Okay? Now, some people just say, oh, it's inside, so I know it's backwards of what I think. And they remember it fine that way, and they're okay that way. You know the math, don't you? You know the math now. Now, do I care if you remember it the other way? I do not. You know that I don't. Okay? But you know the math. Is that fair? All right, let's draw some graphs for it then. So if our parent function is f of x equals x squared, we know that's a parabola that looks like this, right? And if my g of x actually says x minus 3 squared, where the minus 3 is inside the function, which direction is it going to move? 1, 2, 3. So before, this parabola had a vertex at the origin, right? Now, this parabola has a vertex that's to the right, 3, right there. Does that make sense? Okay. Now, I will say this real quick, because I think I forgot to say it at the beginning. This is a magic foldable. And if you know the magic, I'm just asking you to please not ruin it. Let other people get to see the magic for the first time. Is that fair? Okay, thank you. Are we good so far? Okay, so now I just want you to take it and flip it over. So we're kind of back to the front, kind of front, but it's not really the front, it's just the side, right? But we're on the side where we have written transformations and written our name, right? Okay, so on the top box here on this left-hand side, we're going to write a times f of x. Now, let's be sneaky to ourselves, right? And go ahead and tell ourselves out, like, what little word are we going to write up here at the top before we even start? Outside. Because the a is sitting on the outside of the function, isn't it? Now, what were the h and the k doing to the function? What mathematical operations were they doing to the function? Adding and subtracting, right? What is a doing to the function? It is multiplying. So it's not gonna be a shift this time or a translation. This time, well, we know it's outside, so we know it's vertical, right? But this time, it's going to cause a vertical stretch or a shrink. But in parentheses under shrink, I'm going to write compression, because sometimes that's the word that's used. Okay? Almost everybody uses stretch for when it grows or gets bigger, but they don't always use shrink. Sometimes they use compression. Okay? So this is outside, so it's like logical. It's going to do what you think. So if a is greater than 1, what do you think is going to happen? Is that going to be a stretch or a shrink? A stretch, right? Because a is greater than 1, it seems logical that would make a stretch. S-T-R-E-T-C-H. There's an R right there. Please don't judge my R. I mean, you can if you want. It's fine. What's going to cause a shrink? So that is a good start to the answer. Okay? The thing about it is that we are not ready to talk about negative numbers yet. So it does have to be less than 1, but it also has to be greater than 0. So a has to be between 0 and 1. Now, sometimes people say, oh, a fraction. So you're on the right track, right? You're thinking on the right track, but 4/3 is a fraction. But 4/3 is greater than 1, isn't it? So just be careful with that thinking, okay? Let's draw the graphs real quick. So this time let's say f of x is the absolute value of x. And this time let's say g of x is 3 times the absolute value of x. So we know the absolute value of x looks like a v. If this is a vertical stretch, that means I'm taking it and stretching it this way, right? I'm vertically stretching it. Well, this has an ending point, so for this particular graph, it's like I'm putting my finger on the end of the ending point, grabbing hold of the graph and stretching it this way. So is it logical to you that now it looks like this? Good. Very good. Okay? Any questions? f of bx. B is where? Inside. Inside causes what kind of change? Horizontal, very good. And because B is multiplying, what kind of change is it? Very good. Stretch or shrink. Now, do I need to put compression under there as well, or is that something you can remember? You can write it in there if you want. I'm not going to. Are you okay with that? Now, but this is horizontal. It's inside, so that means it's backwards, right? Backwards of what we think. So it's going to cause a stretch between 0 and 1. Very good. What's going to cause a shrink? If B is greater than 1. So if f of x is x squared, we know that's a parabola. And if g of x is, in parentheses, 1/2 x, and then squared, I'm doing a horizontal stretch, which means I'm horizontally taking it and pulling it this way, so it's ending up like that. Does that make sense? All right, you ready for the magic? You don't seem that excited about the magic. All right, you ready? I'm going to close it up and turn it back to the first side that I worked on. And then I'm going to open up the middle. Yep, right there. Perfect. You got it? So here, close it, and then open it. So close it, and then open it. You good? Yes, right there, right there. Okay, you ready? Negative f of x. Where's the negative? Oh, geez. Where's the negative? On the outside. If it's outside, it causes a vertical change. It is a reflection. Okay, this change is a reflection. If it's a vertical reflection, what is it reflecting over? Over the x-axis. Can we get the other side written real quick before I draw the graphs? Is that okay? So this one is f of negative x, and it is inside. You know it because it's inside, it causes a horizontal change. And you know because it's a negative, it causes a reflection. And a horizontal reflection would reflect across what? The y-axis. I just know the bell's about to ring, so I wanted to get that information to you. Please remember that your homework is on my textbook. Okay? I'm going to finish this, and you know it's on the video that'll be on Classroom if you need to watch the rest of it to draw the graphs. Okay? If you want to draw them right now, that's also perfectly fine. Otherwise, I hope you have a wonderful, wonderful rest of your day. This is our parabola. Reflected over the x-axis, this is our parabola. Okay? If our f of x here is 2 to the x, that's exponential growth, like that, which means our g of x would be 2 to the negative x, reflecting across the y-axis, like this, would be like that. Okay?